Atlantis Resources Corporation, over the last decade, have pioneered the development of tidal current power as a reliable, economic and secure form of renewable energy. World leaders, Atlantis owns patented, economically viable tidal current turbine technology. The AR1000 is the latest turbine to be deployed and commissioned. The journey starts in the northeast of England at Francis Brown, who are leading providers of fabrications. Large plate steel is being rolled and welded to form the nacelle. The nacelle is the major structural element of the turbine. It houses the turbine power train, the components that capture the power of the tide and convert this motion into electrical energy. Welding components this large is a highly specialist process and requires the metal to be preheated. To achieve a consistent weld in the most efficient manner possible, the welders work around the clock to complete this one weld. SMD specialise in building subsea vehicles, and we are drawing upon their expertise to ensure that the AR1000 is rugged enough to cope with the extremely demanding marine environment it will encounter. Their facilities are being used for the assembly of the turbine. Purpose-built jigs and lifting rigs have been constructed to safely assemble the inner workings of the turbine. The brake unit weighs 6.2 tons and has been designed to assist with the control of the turbine. In extreme conditions, it must bring the turbine to a complete stop within 5 seconds. The shaft also weighs 6.2 tons and must be rigid and strong enough to withstand the immense bending moments that will be forced upon it while enduring the might of the winter storms off the north of Scotland. To ensure longevity of the turbine, the precise alignment of the shaft is critical. The rotor blades are designed to rotate once every 8 seconds. However, for the generator to produce electricity at the correct rating, it must rotate approximately 6 times faster. This is where the gearbox comes in. Low maintenance and reliability is vital, and the gearbox has been purpose-built with this in mind. The permanent magnet generator is a state-of-the-art generator offering the highest electrical generation efficiencies possible. As the generator housing is a structural member, it must be strong enough to withstand the rigors of the subsea environment. It is vital that the nacelle is kept 100% watertight, and the turbine is fitted with moisture sensors to warn of any ingress. However, prevention is better than cure, and as each module goes together, the joining flanges must be tested for watertightness. This is achieved by temporarily putting a vacuum between the double O-ring seals. All of the seals are duplicated, and we only use sealing components that have been proven in similar marine environments. At this stage, the nacelle weighs 83 tons and is over 8 meters long. The control room will be sited within the substation on the shores of Eday. Within this unit lives the nerve center of the AR1000. These systems control the speed of the nacelle and the power it generates. The turbine's sensors and cameras can be viewed remotely, and the operating parameters adjusted via an ADSL link. All of the electronic components have been tested prior to being fitted into the nacelle, but this is the first opportunity that the team has had to ensure that all of the sensors and the turbine's central computer communicate correctly. Access hatches in the nacelle enable the easy replacement of most electrical components, and the modularized assembly system allows wiring looms to be removed and checked. The turbine is then hooked up to the control room and energized with a 3.8 kilovolt supply. The generator is run in motoring mode, and the powertrain is fired up for the first time. On completion of the initial testing, the 2 hubs are fitted and then loaded onto a low loader for the journey up to Scotland to meet up with the gravity base structure. The turbine has an 18-meter diameter rotor, enabling the AR1000 to generate 1 megawatt at a water speed of 2.6 meters per second. In order to withstand the dynamic forces induced by the waves and tide, the foundation for the turbine must weigh more than 1,000 tons. The mass of each major component is limited by the rating of the lifting equipment on the installation vessel, and so each component must weigh no more than 200 tons. For this reason, the supporting structure has been broken down into a steel frame and 6 steel ballast blocks. A state-of-the-art dynamic positioning vessel is being used for the installation. Its precise positioning capability negates the need for anchorage, reducing the installation footprint and ensuring a minimal environmental impact. With the turbine and its base secured to the deck, the vessel will depart for the Orkney Islands to commence the final stage of its journey. In 2011, Atlantis Resources Corporation introduced a revised commercial-scale turbine offering to the market. The AR1000 was deployed at the European Marine Energy Centre Orkney in August of 2011, complete with GRP blades manufactured in the south of England using Atlantis's patented blade design. The turbine nacelle is transported to the quayside by a low-loader lorry. A Class 2 dynamic positioning vessel is used for the construction work. The nacelle and its transportation frame are loaded onto the construction vessel using the vessel's crane. Once on deck, the transportation frame must be welded to the deck's structural members to ensure that the load is safely secured for the transit to the tidal site. Meticulous planning and coordination is required to ensure that the vessel hire period is kept to a minimum and that all work is carried out as safely and effectively as possible. The dynamic positioning vessel uses its GPS system and a series of powerful thrusters to accurately hold station above the foundation. With no need to set moorings or anchors, there is no compromise to the electrical infrastructure on the seabed, and this also helps to minimize any environmental impact. The crew must prepare the nacelle so that it is ready to be deployed as soon as the tide drops below a permissible flow rate. As the nacelle is lowered on the ship's crane into the tidal stream, a series of guide wires are used to control the orientation of the nacelle, thereby enabling the accurate alignment of the nacelle with the foundation. Previously, Atlantis's turbines required remote operating vehicles, or ROVs, to assist with the positioning of the turbines subsea. This limited operations to those periods when the tidal flow was less than 2 knots. As a result, Atlantis have now developed and patented the nacelle intervention tool to deploy and recover the nacelle over a wider operating window. Once the stab connection has been accurately aligned, the nacelle is lowered into position. From this point on, the force of gravity alone is enough to securely hold the turbine in position. The nacelle intervention tool is then decoupled from the nacelle and recovered to surface. This mechanism is hydraulically driven and activated from the vessel. The connection management system is hydraulically mated, providing the turbine's electrical connection to the grid. The operation is not dependent upon neat tides and can be carried out in swells of up to 2 meters. The power electronics for the AR1000 are housed on shore, and as soon as the turbine is installed, the Atlantis team wasted no time in putting this state-of-the-art commercial-scale turbine through an intensive commissioning program. By using a direct torque control system, Atlantis is able to automatically control the rotor speed and maximize the power output from the turbine. A single-stage planetary spur gearbox drives the 1 megawatt synchronous permanent magnet generator. The resultant electrical energy is transported to shore, where it is converted to fully grid code compliant electricity for domestic and industrial use. The turbine is fitted with a full onboard health monitoring system and SCADA-linked remote control, which can operate the electromechanical rotor control system and the hydraulic parking brake. The brake is equipped with a pre-programmed fail-safe, which ensures that the turbine safely shuts down in the event of loss of grid or any other unexpected failure. Atlantis's service technicians aim to maximize energy production from the tides. and ensure that the turbines operate reliably and with minimal maintenance costs during their operational lifespan. The intervention philosophy by which Atlantis operates is based upon prevention rather than cure. However, through a series of open ocean sea trials, Atlantis has proven that the nacelle retrieval can be executed in less than 60 minutes. Through continued testing and development, Atlantis has de-risked the deployment of its turbines, enabling this highly competent team to complete the connection of a nacelle in less than 90 minutes. By using Atlantis's nacelle intervention tool, the use of divers can be avoided. This removes a significant health and safety risk, whilst also increasing the operational windows in which these procedures can take place. An important factor in ensuring that tidal energy becomes a commercial reality. Here we can see the original recovery system, which was dependent upon an ROV. Here the ROV is being used to guide the nacelle intervention tool onto the nacelle. The newly patented nacelle intervention tool achieves this without the need for a ROV. The nacelle is hoisted ashore with the vessel's crane, which enables first-line maintenance to be carried out. Harnessing the unlimited power of the ocean is a major global challenge. With our commitment to ongoing research and development, Atlantis has been selected as the marine power systems supplier to some of the largest marine power projects in the world.